Bismillahirrahmanirrahim. My name is Malaika and I am from the Department of BS Chemistry. Today I am going to present a presentation on Fiddlecraft reaction and its some types. So first of all we need to know that what are basically Fiddlecraft reactions. So the Fiddlecraft reactions are a set of reactions developed by Charles Friedel and James Kraft in 1877 to attach substituents to an aromatic ring. Basically, these are coupling reactions. Fiddlecraft reactions are of two main types, alkylation and acylation. Both proceed by electrophilic aromatic substitution. First, we'll talk about Fiddlecraft alkylation. So, the introduction of an alkyl group in the benzene ring in the presence of an alkyl halide and a catalyst aluminum chloride is called Fiddlecraft alkylation. The overall reaction is given in which you can see that a benzene ring is attacked by an alkyl halide in the presence of aluminum chloride and it is forming a alkyl benzene. Now we look towards its mechanism. In the first step, electrophile generation is occurring. Then in the second step, this electrophile will attack on the benzene ring and aluminum tetrachloride will be released as a byproduct. Then in the third step, as we know that catalysts are recovered at the end of the reaction in the state in which they were inserted. So that's why aluminum tetrachloride will abstract one hydrogen from the benzene and then alkyl benzene with aluminum chloride and HCl is produced. This was Fiddlecraft alkylation. Now talking about Fiddlecraft acylation. Both have the same mechanism, just the difference is that in the Fiddlecraft acylation, the introduction of an acyl group in the benzene ring by substituting the hydrogen of benzene ring in the presence of an acyl halide and a catalyst aluminum chloride is called Fiddlecraft acylation. The overall reaction is also same in which a benzene ring is being attacked by an acyl group in the presence of aluminum chloride and then acyl benzene is formed. Its mechanism is also similar to that of Fiddlecraft alkylation. In the first step, the electrophile will be generated. In the second step, the electrophile will attack on the benzene ring. And in the third step, aluminum tetrachloride, which was formed in the second step, will abstract a hydrogen from the benzene ring to form acyl benzene with aluminum chloride and HCl as a byproduct. These two were the main types of Fiddlecraft reactions. Now we'll see some other types of these reactions. For example, Clemmenson reduction. Clemmenson reduction is a chemical reaction described as a reduction of ketones to alkanes using zinc amalgam and concentrated HCl. This reaction is named after Erik Christian Clemmenson, a Danish chemist. It is basically an organic redox reaction. The overall reaction is given in which you can see that a ketone in the presence of zinc amalgam and HCl is reduced to alkane. Now we'll see its mechanism. So in the first step, the ketone is protonated and then its two resonating forms of the products are shown here. Then in the second step, the product form will be again protonated in the presence of zinc to form an alkane. Talking about its applications, so this reaction has widely used to convert a carbonyl group into a methylene group. It has also an important application in the preparation of polycyclic aromatics and aromatics containing unbranched side hydrocarbon chains. To reduce aliphatic and mixed aliphatic aromatic carbonyl compounds, the Clemmenson reduction mechanism is also used. For example, you can see here that heptanyl in the presence of zinc amalgam and HCl, it is reduced to heptane, which is an alkane. Now talking about Hoist reaction. The Hoist reaction or Houber-Hoist reaction is an organic reaction in which a nitrile reacts with an arene compound to form an aryl ketone. The reaction is a type of Fiddlecraft acylation with hydrogen chloride and a Lewis acid catalyst. This is basically a coupling reaction. So you can see in the overall reaction that an nitrile is reacting with an arene compound and aryl ketone is formed. Now we'll talk about its mechanism. So as you can see that in the first step, Nucleophilic addition of the nitrile is happening with the aid of a polarizing Lewis acid, and a amine is formed. And in the second step, the amine formed in the first step is hydrolyzed to yield aryl ketone with the reduction of amine. Now talking about its application, so this reaction has been used for the acylation of phenols, their ethereal derivatives, and some heterocyclic compounds. Next reaction is Scholl reaction. The Scholl reaction is a coupling reaction between two arene compounds with the aid of a Lewis acid and a protic acid. It is named after its discoverer, Ronald Scholl, a Swiss chemist. It is basically a coupling reaction, as I have told you earlier. Now talking about the overall reaction, then you can see that two aromatic rings combine in the presence of aluminium chloride and a proton to form a two coupled benzene rings. Now talking about the mechanism, so the exact mechanism is not known but could very well proceed through an arenium ion. Just as in the electrophilic aromatic substitution, activating groups such as methoxy improve yield and selectivity. So two mechanisms are described for the coupling of two benzene rings. First is radical cation mechanism and the second one is arenium ion mechanism. Talking about radical cation mechanism, so in this first step of this mechanism, a radical cation is formed from one reaction partner by oxidation. In step 2, the radical ion attacks the second neutral partner in a substitution reaction and a new radical ion is formed with the one ring bearing the positive charge and the other one with the radical position. And in the third step, dihydrogen is split off with re-aromatization to the bi-aryl compound. Next is arenium ion mechanism. In this one reaction partner is protonated to an arenium ion, which is then attacked by the second partner. Next reaction that I am going to explain is Zincke-Scholl reaction. The Zincke-Scholl reaction is a special case of Fiddlecraft Acylation and was first described by Theodor Zincke and Scholl in 1906. Unlike the traditional Fiddlecraft reactions, the reduction of the phenyl ring leads to a higher energy final product that can be used as starting material in the di-enol benzene rearrangement. Now the overall reaction is given in which phenyl ring is reduced in the presence of aluminium chloride and carbon tetrachloride to a di-enol product. Now talking about its mechanism, so in the first step, here basically in these reactions, aluminium chloride is playing a range of functions. In this first step, it is reacting with paracresol to form phenoxyaluminium chloride along with a molecule of HCl. But the molecule of HCl formed is then reduced. In the second step, aluminium chloride is activating a molecule of carbon tetrachloride that in turn is subjected to a nucleophilic attack by the phenoxyaluminium chloride, as you can see. In the third step, the product interacts with aluminium chloride and carbon tetrachloride again to form a loose complex. And here in the fourth step, finally, the product is treated with water, resulting in the final product. Talking about the applications of reaction, so its products can be used as starting reagents for the di-enol benzene arrangement. This is an important reaction for the artificially producing biologically relevant molecules, including the A ring of steroids. The most important application of the Zincke-Scholl reaction is its potential following von Or's arrangement. Next we have Blanc chloromethylation. It is also known as Blanc reaction and is the chemical reaction of aromatic rings with formaldehyde and hydrogen chloride catalyzed by zinc chloride or other Lewis acid to form chloromethyllerenes. The reaction was discovered by Gustave Louis Blanc in 1923. The reaction is performed with care as like most chloromethylation reactions, it produces highly carcinogenic bis-chloromethyl ether as a byproduct. This is basically a substitution reaction As you can see in the overall reaction that benzene in the presence of zinc chloride and HCl, it is being substituted by a halogen atom. Talking about the mechanism of this reaction, so in the step 1, formaldehyde is protonated. Formaldehyde's carbonyl compound is protonated so that electrophilic carbon can be made. In the second step, the aldehyde is attacked by aromatic pi electrons followed by the re-aromatization of the aromatic ring. And in the third step, you can see that the benzyl alcohol formed is quickly converted to chloride under the reaction conditions. Talking about the applications of this reaction, so although the reaction is an efficient means of introducing a chloromethyl group, the production of small amounts of highly carcinogenic bis chloromethyl ether is a disadvantage for industrial applications. The corresponding fluoromethylation, bromomethylation, and iodomethylation reactions can also be achieved using the appropriate hydrohalic acid. Now coming towards Darsen's reaction. This reaction is also known as Darsen's condensation or glyceric ester condensation, and it is the chemical reaction of a ketone or aldehyde with an alpha haloester in the presence of a base to form an alpha beta epoxy ester, also called a glycidic ester. This reaction was discovered by the organic chemist August Georges Darzens in 1904. Basically, this is a ring forming reaction. Now, as you can see, the overall reaction which is given, in which a ketone is reacting with a haloester to form a alpha beta epoxy ester or glycidic ester. Talking about the mechanism of the reaction, so in the first step, strong base is used to form a carbanion at the halogenated position, and the two resonating forms of the product are being shown here. In the second step, the nucleophilic structure attacks another carbonyl component, forming a new carbon-carbon bond. And in the third step, the oxygen anion in this aldo-like product then does an intramolecular SN2 attack on the formerly nucleophilic halide bearing position, displacing the halide to form an epoxide. SN2 reaction is basically a substitution nucleophilic one-step reaction in which bond making and bond breaking are simultaneously can be seen in the one step. Now talking about the Haworth reactions. The Haworth reaction is a classic method for the synthesis of 1-tetralone. In this reaction, benzene is reacted with succinic anhydride, the intermediate product is reduced and a second Fiddlecraft acylation takes place with addition of an acid. As you can see here. You can see here that a benzene is reacted with succinic anhydride, and then the intermediate product that is formed, it is reduced, and the second Fiddlecraft acylation takes place when an acid is added. Now, in a related reaction, phenanthrene is synthesized from naphthalene and succinic anhydride in a series of steps which begin with Fiddlecraft acylation. Now basically this formation is a multi-step process. As you can see, there are many steps like Clemmenson reduction, cyclization and reduction, and dehydrogenation. This synthesis is also known as Haworth phenanthrene synthesis. Same procedure used for the preparation of naphthalenes from benzene is called Haworth reaction. Talking about the applications of Haworth reaction, Haworth reaction has a wide application in preparation of fused aromatics including naphthalenes and phenanthrenes. Now talking about Nanky reaction. Phenyl salicylate or salol is a chemical substance which was synthesized first in 1883 by the Polish chemist and doctor Marcel Nanky, and then independently in 1885 by the German chemist Richard Seifert. It was synthesized by heating salicylic acid with phenol. Once used in sunscreens, phenyl salicylate is now used in the manufacture of some polymers, lacquers, adhesives, waxes, and polishes. It is commonly used in school laboratory demonstrations on how cooling rates affect crystal size in igneous rocks and can be used to demonstrate seed crystal selectiveness. Salol is also used as an internal antiseptic and as a mild analgesic. This is a chemical diagram. This is a chemical structure explaining the structure of cellule. Now talking about Bogart-Koch synthesis. This reaction is the two-step process for preparing octahydrophenanthrene derivatives from a Grignard reaction between beta-phenylethyl manganese bromide and cyclohexanes, followed by the cyclodehydration of the tertiary alcohol with concentrated H2SO4. And then the intermediate carbinol is treated with a milder dehydrating agent and found to cyclize to octahydrophenanthrene derivatives. That's all about Fiddlecraft alkylation reactions and its types. Thank you.